Alright, hey, how's it going, guys? Thanks for tuning in. If you're here, it's because you need a little more help for tomorrow's quiz, and hopefully you can get it. So looking here, this is the exact same problem from the worksheet that we already did. So if you want to hear me do that again, that's great. If you don't, then you can fast forward a little bit, because I found another similar problem. And what you can do is you can pause the video and try it yourself on a piece of scrap paper, and then I'll explain it. Okay, and I did that for the first few problems. I didn't really do it for the proofs. Proofs are kind of hard, but at least for the first three problems or so, there's a new problem here that you guys can try on your own, and then I'll go over it with you. But I am still going to go over the stuff from the worksheet too for the people that were absent or the people who just want to hear it again. Anyway, let's start right now. Looking here, you've got to read everything in geometry class first of all. So it says, given the diagram, if ED bisects AC, that's hugely important that you read that word bisect, because if ED bisects AC, then you now know that segment AB and segment CB are the same length. So that means now when you read the next part where it says that AB is 3x minus 8, you can label that. And it says BC is x plus 4. And now because you read that this thing was a bisector, you now know that these things are congruent. So you know that the way to solve this problem is to take the 3x minus 8 and just set it equal to the x plus 4. And that's it. That's the relationship. Okay. So now to solve algebraically, we don't want to have x's on both sides of the equation. So you find the smaller number of x's and you subtract it away from that side. But if you do it to this side, you have to do it to this side too, to keep that balance. So by subtracting, on this side they cancel out, and now the only thing left is the 4. On this side, 3x minus x is 2x. And of course you still have the minus 8. Now that x is only on the one side, we want to now get this x alone. That means getting rid of the 2 and getting rid of the 8. To get rid of the 2, you'd have to divide. To get rid of the 8, you'd have to add 8. We always add or subtract before we multiply or divide when we're doing algebra. So when we're doing algebra, I'm going to add 8. That'll make those 8's cancel. And I'll still have my 2 stuck to the x, but I'll be able to get rid of that in the next step. So 4 plus 8 is 12. Now to get rid of the 2, I divide by 2. Dividing is the opposite of multiplying. So you can undo the multiplication by 2 by dividing by 2. It cancels out, and you now have x equals 6. So that's how we found out that x is 6. Now, they also want to know the length of AC. Well, AC is this whole segment. So we know that that whole segment would be the 3x minus 8 plus the x plus 4. So we can just find those two pieces and add them together. So we know that the measure of segment AB is given by the expression 3x minus 8. But we now know what x is. So we can actually plug in for x the 6 that we just solved for. So instead of x, we get a 6. And then we just do this math. 3 times 6 will be 18. And from that we want to take away 8. So that tells me it's 10. But remember, we weren't really after AB. We wanted the total length from A to C. But if this piece is 10, don't forget we already knew that the two pieces were the same. So this piece has to also be 10. And that means the total length is 10 plus 10, which is 20. And now we're done. We have both of those values. So now, if you want another chance at a practice problem like that last one we just did, then click pause, pause the video, and do this problem yourself. Although I guess I should label. Sorry. What does it say? CT. So these endpoints are CT. And the midpoint is A. This is A. Oh, cat. How cute. Anyway, solve it. Click pause now. Okay, if you are hearing me, it means you've unpaused, and now it's time to go over it. So what does it mean for A to be the midpoint? That means the same thing from the last problem, when we had a line segment that was a bisector. The bisector cut the segment into 2 equal parts. Well, a midpoint does the same thing. It cuts a segment into 2 congruent parts. So when they tell you that CA is 2x plus 8, when they tell you that AT is 4x plus 2, then we would approach this problem the exact same way we approached the last one, knowing that these two values have to be equal. So you just grab them and set them equal. I don't know where that 3 came from. 2x plus 8 equals 4x plus 2. And again, I like to combine the x's first. So I look for which side has the smaller number of x's. This side has only 2. So I'll subtract 2 from here. And they'll cancel. I'll have 8. That now equals 4 minus 2. So only 2x plus 2. Then I need to add this 2 to make it cancel out. So I'll add 2 over here as well. I get 10 equals 2x. So finally I can divide by 2 to get 5. Now they also want to know the length of CT. And again, CT is the whole thing. So I would recommend that if you want to find the length of CT, just find the length of CA and then figure out the length of AT and add them together. And that'll give you the total length of CT. So let's say for CA, we know it's 2x plus 8. But remember, we just figured out what x was. So we can take x and substitute it in. We'll have 2 times 5 plus 8. That's 10 plus 8. That means we have 18. But again, that 18 is only CA. What do you think AT is going to be? Well, it's going to be the same, because remember, A was a midpoint. So if CA is 18, then TA is also 18. Now, it's a good idea to maybe double check. You could grab your 4x plus 2 and plug the 5 in for the x. I messed something up. What have I done? Okay, hey, I'm glad I checked. Because guess what? 4 times 5 is 20. Plus 2 is 22. Those should not have come out different. Those should have been the same. So I screwed something up when I did this problem. So 2x plus 8, 4x plus 2. Oh, geez, it's right here. See? I have plus 2 and I was supposed to subtract 2. I'm sorry, everybody. Better rewind. We gotta go way the heck back. To this moment in time. Okay, if I knew how to edit, I would edit this video, but I don't. So, sorry. Hey, we should be subtracting 2. And then you get 6 equals 2x. And then you divide by 2. So you get 3. Boy, I'm glad I double checked this. Okay, hey, great. Now we know that when we go to plug the 3 in, we get 2 times 3 plus 8, which is 6 plus 8, which is only 14. And then this other side should be 14. And this time if we go 4 times 3 plus 2, then we get 12 plus 2, which is 14. So they did come out the same. So now I know that 3 is right. I haven't made another mistake. I apologize again for that. But this means that the total length of CT is the 14 plus 14, aka 28. So there's your 2 values. Sorry, I made a bit of a mess of that, but hopefully you guys get it now. Okay, next. Here's the problem that we already did from class. And here's another similar problem that I found. So again, you guys can try this one on your own if you want to, and then check yourself. But let me go over the original first. It says that BD bisects angle ADC. So make sure you're looking at the right angle. Angle ADC is the one here on the right. And so we now know that those 2 pieces of that angle are congruent. And then the problem goes on to say that ADB, that's the top half, is x plus 14 degrees. And it says that CDB, the bottom half, is 2x minus 2 degrees. So we know again that we'll just take those things and set them equal to each other. So you'll take the x plus 14 and set it equal to 2x minus 2. So let's see if I can keep my algebra straight this time. You're going to subtract x. That cancels. You have only 14. and it equals 1x minus 2. So now to solve, you just add 2, and it cancels, and you get 16 equals x. Now, same old thing. They want you to go back and find the measure of angle ADC, with angle ADC being this whole entire angle. So you can see it's going to be whatever we get for the x plus 14 plus whatever we get for the 2x minus 2. So let's grab that x plus 14. Let's substitute our 16 in where the x used to be, and we see that 16 plus 14 is 30 degrees. So the top half of this angle is 30 degrees. And that means that the bottom half is also 30. Now we just saw in the last problem that I screwed up my algebra, so you might want to double check yourself one last time. So you've got the 2x minus 2, right? Let's just make sure that when we plug in 16 it actually gives us 30 like it's supposed to. So we're getting 32 minus 2, and yes, that's 30. Okay, so I know that 16 is correct. I know that the 30 and the 30 are correct. So the total measure of the angle is 60. And then you're done with number 2. So now that you understand 2, here's this extra practice problem. Again, pause the video. If you want to try it yourself, click pause, do it, and then check yourself against me. Okay, so it says here that BX is the bisector. So exact same situation that we had before. We've got an angle that's been chopped in half. And they're telling us that ABX is 5x. So this half is 5x degrees. They're telling us that the bottom half, XBC, is 3x plus 10 degrees. So we'll do this the same way we did the last one. We'll state that these two expressions equal each other. So the 5x and the 3x plus 10, they're just equal. And so we'll solve by getting rid of the smaller number of x's. I'll subtract that 3x from both sides. That makes it cancel on this side, and would still have the 10 that we bring down. And it reduces the number of x's I have over here. I now have 5 minus 3, so only 2 x's. Oh boy, I think it's too late at night for this for me. Okay, this canceled out. There's not still an x over here. That's my bad. There's nothing left except for the 10. I am sorry, I'm rusty. Okay, so now to get x alone, you only need to divide by 2. And you'll get x is 5. So hopefully you guys got 5 also. Now, they do want you to also find the measure of ABC, ABC being the whole thing. So again, we're just plugging in. For the 5x part, it's going to be 5 times 5, which is 25 degrees. For the 3x plus 10 part, that'll be 3 times 5 plus 10, which is 15 plus 10, which is 25, which is good news. We knew that those things were supposed to come out to be the same, and they did. It's 25 and 25. So that means the whole angle, the measure of angle ABC, is 50 degrees. Oops, 50 degrees. So there, you got both parts now. Hopefully this is helping you. I know I keep making little mistakes, but I'll try to stop. Moving on. So here's 3. For this problem, we talked about how in any triangle you ever see, the 3 angles of the triangle all will add up to 180. That will always be true. So this time, you'll take the 3x plus 41. You'll take the 2x minus 5. And you'll take the 7x. And you're going to say that all 3 of those things added together would give you a grand total of 180. So we got to solve that. So you'll take the 3x, the 2x, and the 7x. Those are all like terms. So when you add them up, 3x plus 2x is 5x, and 5x plus 7x is 12x. Now, go after the whole numbers. You've got this 41 minus 5, and this part has no whole numbers, so you just have to combine these two. but you'll have a positive 36. And then that's going to equal 180. So this is the new simplified version of our equation. So now, to solve, you would want to subtract 36 from both sides. Those 36's will cancel. You'll just have 12x. And 180 minus 36 will leave you with 144. And now you can divide by 12. And 144 divided by 12 is 12, because 12 times 12 is 144. So we get 12, and that's all they wanted here. They said for each of these problems, just find x. And so we found x, that's all there is to it. Now, I gave you another one of these. I found another problem. So this time I'm saying solve for x, and then also go back and find the measure of the largest angle. Okay. So again, if you want to practice, pause the video and try this one. And when you're done, come back and we'll go over it together. Okay, if you're back, then to solve this problem, you would take the exact same approach as before. We still have the three angles of a triangle, which always have to add up to 180. So the x plus 40 plus the 2x minus 5 plus the 3x minus 17 should add all the way up to 180. Again, look for those common factors, those like terms. You've got an x, a 2x, and a 3x. Then for the whole number parts, you've got a positive 40, a negative 5, and a negative 17. So if we combine all those terms, we can start to simplify this side. So x and 2x is 3x, plus 3 more x's would be a grand total of 6x. Then 40 take away 5 is 35, and then 35 take away 17. I'm going to screw this up. Feels like 18 to me, doesn't it? Reduce. Yeah, 18. You guys will have a calculator on you, I hope. So plus 18 equals 180. So now we can start to isolate x by subtracting 18 from both sides. They'll cancel. You'll have 6x equals 162. Then you can divide by 6. Cancels. And you get x equals. Again, you'll have a calculator, but this is going to be what? 27? Yeah. Sounds good to me. So that's x. Now the second part where I said solve for the measure of the largest angle, you can kind of just eyeball this. It certainly seems like this one is the largest one. It looks like it should be almost 90 degrees, and the other two are smaller. So assuming we're drawn to scale, we can just solve that. So we'll go 3 times 27 minus 17. That's going to be 81 minus 17. That's going to be 64. I think that's right. Okay, so here's the problem. I don't think this picture was drawn to scale. And I want my calculator to double check this work I'm doing. So 3 times 27 is definitely 81. And 81 minus 17, that's actually 64, so I'm right. But here's the deal. That's not the largest. Because if you look at this guy, x plus 40 is going to be 27 plus 40. That's 67 right there. And so that's bigger. So this is definitely one of those, picture not drawn to scale things. So it's actually this angle down here whose measure is the greatest. Just for the sake of argument, the 2x minus 5, that would be 2 times 27 minus 5. That would be 54 minus 5. That would be 49. Yeah. So that guy's the smallest. I would have said that guy was the middle value. This was the smallest and this was the biggest. But you can't trust You can't trust what the diagram looks like. You'd really need to find them all and then say this one's the biggest, the 67. All right, time to get on to proofs. I lied. We're not getting on to proofs just yet. There were a couple more examples. This one's the same deal. You know that this was supposed to be a plus sign, not a division sign. That's just kind of where the worksheet got messed up. But to solve this problem, you certainly could say that it's x plus 5 plus 2x minus 2 plus that 90-degree angle. Don't forget about it. You'd have to include that too. And all three of those guys would add up to 180. I did have at least one kid mention, though, that these two angles all by themselves, the ones that aren't the 90-degree angle, they would have to add up to 90. And of course that's true as soon as you look at this, because if all the angles add up to 180, then if you take the 90-degree angle out of the equation, then you see that you have the other two, the x plus 5 and the 2x minus 2. Well, they would have to add up to the remaining 90 degrees. So some of y'all, if you notice that, you could definitely just start your equation here, knowing that the two angles in a right triangle that aren't the 90-degree angle would have to add up to 90 all by themselves. And you could just start here. But let's solve this now. We've got 2x plus another x, so that's 3x. The 5 and the negative 2 make a plus 3, and that equals 90. So subtracting 3 gives me a 3x that equals 87, and then dividing by 3 gives me what? 87. If I divide by 3, it's going to go in twice. That's a 6, leaving 2, drop the 7, that goes in 9 times, 29. If you don't want to do long division, bring your calculator. And that's it for that problem. That thing's 29. On the quiz, there's a pretty good shot that I'll ask you to go back and find the measures of these other angles. If I did, you're just plugging in the 29. 29 plus 5 says that this angle is 34 degrees. And 29 doubled is 58, take away 2 is 56. So, now you know all three angles. You know you've got 90, 34, 56. If they asked you to do that, then you would now know how. Alright, so I don't have another practice problem like this. I don't have any more practice problems. So here's another one from the worksheet. We said that this one you could do because these two angles are a linear pair. So you do 180 minus 100 to figure out that this one's 80. From now on, you're just ignoring that 100. This question is about these three inside angles of a triangle that you know have to add up to 180. So you can take the 80 and add to it the 2x plus 3 and add to that the 51. Set that whole thing equal to 180. Now normally I would tell you to combine everything that's on this side, but it would actually be pretty smart, wouldn't it, to just subtract 80 right now? Because if you just cancel that 80, then this side goes down to a nice clean 100, and you could work from there. That's fine. That's a legal mathematical move to make. So now you'd only have this part to deal with. So you'd have a 2x plus 54. And if you work the problem from here, you'll still get the same answer. So let's subtract 54. That cancels. You find that 2x equals 46. And then you divide by 2. So x is now equal to 23. And that's all she wrote for that one. On the next problem, I said don't do it. Just literally, please just ignore it. If for some reason I ever have to go back and teach this to you, I will, but I do not care about this rule. Ignore it. Moving on. So now we're on to the perpendicular bisector idea. And so for this problem, you certainly have to read again to remember that line M is a perpendicular bisector. First part, bisector, means that the segment's getting chopped in half. So you know that AD is congruent to BD. And then right away you see that they're giving you expressions for those two pieces. So if AD is 5x plus 2, and BD is 7x minus 8, then we are right back to those problems where you'll just take those two expressions and set them equal to each other. So don't worry about the other two for now. I don't need them. If you want to solve for x, these two are all you need. So you'll grab your 5x plus 2, set it equal to your 7x minus 8, and you'll start solving. Again, I look for the smaller number of x's and I subtract them from both sides to get them to cancel out. So they're gone, and I just have 2. And now over here I'm left with only 2 x's minus an 8. So I will now add 8. That brings this up to 10. It equals 2x, and dividing by 2 gives 5. So x is 5. And so now I'm worried about y. For y, the only y expression you have is where it says 4y plus 10 is equal to AP. Now you don't even see anything at AP, and that's okay. You could always draw it in yourself if you wanted to. But they're just trying to tell you that 4y plus 10 is representing that distance, the distance between point A and point P. And then they gave you BP also, so they're giving you this distance too. And that's where our theorem kicks in. We were told that any point on the perpendicular bisector is equidistant from the ends of the line segment. Equidistant meaning these two distances are the same. So when they said BP is 38, they're telling you that if this is 38, then 4y plus 10 also must equal 38. So we can set up our equation then by taking the 4y plus 10 and setting it equal to 38. And then from there we solve. So I'd be subtracting 10 from both sides to get rid of the 10. That leaves me with 4y, which equals 28. Now I can divide by 4. It cancels. I get y equals 7. Okay, so now there's a couple of follow-up questions. They now want to know what's the length of AB, AB being the whole segment. So we'll do what we did before. Remember, we know the value of x. So we can substitute x in for this expression to figure out how long AD is. So instead of 5x plus 2, we'll do 5. And we'll substitute in the 5 for the x. So instead of 5 times x, it'll be 5 times 5, which is 25, plus 2 is 27. So that means the distance from A to D is 27, which should mean that the distance from B to D is also 27. But again, since I messed up that problem before, I don't mind double checking. But 7 times 5 is 35, and 35 minus 8 is 27. So I know I've done it right. So I know my total length is 27 plus 27, so 54. That's how we got AB. And now to find AP, I honestly don't have to do any math. Remember, we said that these two distances should be the same. So since they told me that this one's 38, you just automatically know that this one's 38. Again, you can double check. If you plug in the 7, then 4 times 7 is 28, plus 10 is 38. But yeah, it's 38. And that's it. So I think now we're ready to move on to proofs. Yeah, okay. So a bit of a confession to make. I think periods 1 and 5 got this version of this proof, but period 3, because I didn't pass this packet out to them until a day later, I changed it around a bit. I made some changes, and I talked about these changes with you guys in period 1 and period 5, but you don't actually have this, and that's okay. I'm going to talk you through this again. If I gave you this proof and just said do it, you should be able to, and you will be expected to do this at least once on tomorrow's quiz, where you've got the givens, you've got the proof, you've got the diagram, but you have to do every bit of it yourself. But the first few questions you'll see on the quiz won't really be like that. You're going to have, a question like this, where you see a whole proof that's totally done, and it's just going to ask you, hey, is this proof perfect, or are there mistakes? If there are mistakes, find them and correct them. And we know that for this problem, there were mistakes, because as you read through, it says AC bisects BAD given. That's straight from the given. That's definitely correct. It says AC bisects BCD. Yeah, that's all correct. Then it says AC is congruent to AC. That's that shared side. Well, shared sides aren't congruent because of midpoints. This is wrong. The reason why shared sides are congruent is reflexive property, or just shared side. If you change this to shared side, that would be fine. But remember, it's also called the reflexive property of congruence. So now dropping down, they had said that AC bisects BAD. That means these two angles should be congruent. That's BAC and DAC, and that's what it says here. Definition of angle bisector. That all looks perfect. Then BCA and DCA, that's just these other angles, the ones over here. And that's by definition of angle bisector, so that checks out too. Now if you're keeping score, then you can see that the triangles are congruent by angle side angle. And it says down here angle angle side, so that's definitely another mistake. It should be angle side angle. And then that's it. So Zuko, who said that there were two mistakes, Zuko is right. So you'd have to write a little statement where you say, Zuko is correct. Ang did make two mistakes, and I've corrected them up above. And that's it. So again, if you were actually writing this proof, you can just look here. You see the correct version of it now. This is what it should have been. Moving on. Here's another proof that I think I gave a different version to the other period. So again, should you be able to just do this from scratch, writing every step on your own? Yes, you should. But I know that when the quiz comes around tomorrow, what you're going to see is something a little more like this. I'm going to give you a totally complete 2-column proof, and you just have to take all of those steps and fit them into this flowchart. How well can I make that fit? That's as big as it'll go, right? So let's try this. So for many of these, you could literally take statement 1 and reason 1 and put it right into box 1, statement 1. That's true. I'm not going to deny that. In fact, I'm going to do it. So angle QRS and angle TRS are right angles. That's given. And that's fine. Now, statement 2 says SR bisects QT. That's going to want to go in box 2. Sure. SR bisects QT. That's given. Now the next one says SR is congruent to SR. You're probably going to be tempted to just take what's on line 3 and put it into box 3, but don't do that. Because remember, we've got this arrow here between box 1 and box 3. That means that whatever you put in box 3 has to come directly from box 1. So if you read a little further down, and if you look at the diagram, it says angle QRS. That's this angle here. And TRS. That's this angle here. QRS and TRS are actually from statement 4, and it says they're congruent because all right angles are congruent. It really sounds like that statement is the one that needs to be connected to statement 1. Those are the ones that go together. The only reason why these angles are congruent is because they're right angles. And it's here that we were saying that they were right angles. So you need to put this guy into this box. Otherwise you are not doing it right. So angle QRS is congruent to angle TRS because all right angles are congruent. Okay, so now you're thinking, okay, now I can go back and get the SR thing, and I can put it into box 4, but no you can't, because look, it says SR bisects segment QT. Well, bisecting segment QT means that QR is congruent to TR, and that's down here in statement 5. It even says it comes from the definition of a segment bisector. So step 5 needs to be linked with step 2. You can kind of show it here maybe. Step 2 has to lead to step 5. So in the flowchart proof they have to be connected. I could do the same thing for step 1. Step 1 really has to lead down to step 4. In the 2-column proof it's not important that I actually make a connection. In the flowchart proof it's super important that I make the connection. So here you need to be writing that QR is congruent to TR. and we said it's a bisector, so it's by definition a bisect, because those statements go together. Now, finally, you can go back and take the SR thing and put it here. The reflexive property doesn't need another box over here leading into it. It's just true on its own. So that's why that's the only position where we could put this statement. Okay, had a sneeze there, forgive me. Alright, what did we say? We said we're putting SR congruent to SR here. And this is the only place it's allowed to go. This is a shared side, you can say, if you want to. Shared side is what we've been going with. Alright, now, basically 100% of the time, when you see these three arrows leading into another box, especially when those three arrows are coming out of boxes where we had congruent angles, we had congruent sides, we had congruent sides, that's going to be the congruent triangles. So statement 6 is going in box 6. I don't need to mess with that. It's going to be QRS congruent to triangle TRS. And they gave you the reason. They said it's SAS, and that's true. Again, don't look at the order in the proof, otherwise your order would be ASS. That's not it. The order is how they fit together in the diagram, and I see a side, an angle, and a side. And then lastly, now that we said the triangles are congruent, we now can use Cpctc to prove that any pairs of parts of the triangle are congruent. If they want SQR, that's this guy over here, right? Then sure, those angles now have to be congruent because they're corresponding parts of congruent triangles, so they're congruent. So that part can slide into box 7. Okay, there's that whole proof done. So make sure you're comfortable with that. You should be able to take a proof that's written in one form and convert it into the other form. And hopefully that feels natural. Alright, so now we have another proof, and I think this one I didn't mess with. It says L's the midpoint. Yeah, and then the next one. So this is the one that when you get your quiz, you really will have to just do the whole proof. And so here's my recommendation. You're certainly going to start by just writing the first given into the first box. It says L is the midpoint. Of Jn. And that's given. Okay, fine. Go ahead now and just do the second given in the second box. That's given. Okay, now the other thing you can do pretty safely is take the thing that you wanted to prove and put that in the last box, because you know that as soon as you prove that J is congruent to N, you're going to be all done. Now maybe you don't know the reason yet, that's okay. But look it, we just filled in almost half of the boxes without having to think at all. You just put in the givens, you put in the proof, and that's it. So now ideally you'll be able to kind of work forward from here. This given about Jm being congruent to Nm, you can just mark it. But that doesn't lead us anywhere. That's just a pair of congruent sides. You might label that's one pair of sides, but we still need more. We need 3 pairs of congruent parts, right? But go back here where it said L is the midpoint of Jn. If L is the midpoint of Jn, that means that Jn is getting cut into 2 congruent parts. JL and NL. So that statement is telling you something that you could be putting on line 3. So statement 1 leads directly to line 3 where we can say that JL is congruent to NL. And it's even telling you the reason. We said that L is the midpoint, so the reason is definition of midpoint. Now we also said that there's always something in every diagram that you can find out for yourself. In this diagram we've got the 2 triangles smushed together and sharing a side. So you definitely can say to me that ML is congruent to ML because it's a shared side. Don't forget your hats. And so those are congruent because it's a shared side. And now, what do we got? I think we had some sides. We found another pair of sides. And we just found another pair of sides. So we now have side, side, side congruence. So we're ready to say now that the whole triangles are congruent. So you'll give the first one a name. How about MJL? And so then the next triangle, well, M in this triangle corresponds with M in this triangle. So you better say M first. Then we went to J, and angle J corresponds with angle N. So you know you're going to go MNL. And this proof basically wrote itself now. So now that we know that these triangles are congruent, we know that J and N are going to be congruent to each other because they're parts. They're corresponding parts of our congruent triangles. And that's why they are congruent. It's Cpctc. The last reason is often, very often, going to be Cpctc. I'm not saying always, but I'm saying often. But that's it. You guys can write a whole proof all by yourself because you just take the givens and you start them off. The givens will usually lead you to at least one more statement. Then you can look at the diagram to find one more statement, either the shared side or don't forget the other one that you can often find, which is a pair of vertical angles, right? If you look at the diagram, you'll often find a pair of vertical angles. But then once you've got all your congruent parts, you can say the triangles are congruent, and then you can use Cpctc from there if you need to. And before you know it, you're done with the whole proof. Let's move on. Okay, so there's one last version of a proof. It looks like this one is another proof where you have to do the whole thing, but actually, I changed this one around too. I made a version of this proof where some of the statements were already there for you, but the reasons were missing. Here you've got a statement, but not the reason. On line 5, you've got the reason, but not the statement. And on line 3, you don't have either. So rather than having you do the whole proof, you just have to fill in some parts. So there's some that are kind of easy, some that are hard. This one is like medium. If I were you, I'd still label everything they gave me. So if WZ is parallel to YX, remember parallel, we use an arrow symbol to show that they're parallel, like that. Then it says W and Y are congruent, the angles, so mark those angles as congruent, W and Y. Now you're out of stuff, you got to figure out something to write on your own. Well, how about the shared side? This guy running down the middle. Now the slightly tricky thing here is to remember, does Z in this triangle correspond to Z in the other triangle? Actually, no, it doesn't. And it's very hard to tell, but if I make a long, skinny parallelogram, instead of this thing that looks actually like all the sides are about the same, but if I stretch that out, then when you look at this, there's no way you would think that these two angles go together anymore. You can tell that this one is much smaller. And so now you can tell that that angle should actually be paired up with that one over there. It's a rotational symmetry, not a reflectional symmetry. Why do I bother mentioning that? Because it means that when you go to name those segments, when you name this segment as ZX in the first triangle, well, Z corresponds with X in the other triangle. So segment ZX needs to be paired off with segment XZ. And yes, the order matters. Why are they congruent? Because it's a shared side. Okay, now they're saying that WZX, who is that? WZX, that's this angle right here, is congruent to YXZ. That's this guy here. Well, why would they be congruent? Well, that's that thing we said. Remember when we said on line 1 that these lines were parallel? It's not a bad idea to maybe shade them in, and then you could also shade this guy in because suddenly you've got a transversal, and then suddenly you see the letter Z, right? It's the letter Z, but, you know, rotate it a little bit, and then it lines up, and you got your letter Z. But anytime you see that letter Z, or maybe I should have just said the letter N in the first place, but I typically talk about it as the letter Z, and maybe it's just spun around or reflected or something. But if you see that, and you know that the sides of the letter Z are parallel, that has to be given, then you know that those angles that are stuck into the corners are alternate interior angles. And so that's the justification for the reason on line 4. You're going to say those angles are congruent because they're alternate interior angles, which are congruent. And that's that reason done. So now finally, you just have to figure out the statement that goes with AAS. Well, AAS and ASA and side, 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 and side angle side, all of those are reasons why triangles are congruent to each other. That's the only thing. So you know that line 5 must be the line where we state that the triangles are congruent. So you'll name the first triangle about WZX. And then you'll name the second triangle. So W corresponds with Y, so you definitely have to say Y first. Then we talked about how angle Z in this triangle corresponds with angle X in this triangle, so you have to say X second. So it'll be YXZ. But there you go. We filled in the few blanks of this proof, and now that proof is done. So that's it. So that's kind of the 3 versions of proofs you should expect to see on the quiz tomorrow. You'll have one proof that's totally done but contains errors, and you'll have to find and correct the errors. You'll have another proof where the proof is, mostly done, but you might be missing a statement or a reason here and there. You just have to fill in the missing parts. You'll have another proof where maybe the whole proof is done, but you have to rewrite it as a flowchart proof. And then lastly, there'll be definitely at least one proof that you just have to do the whole proof. You've got the givens and the proof, but you don't have anything else. You have to come up with every statement and every reason all by yourself. But that's it. Is there anything left? No, that's the whole packet. So hopefully this was helpful. I'm going to make another video in a second that shows you some of the delta math activities that I'm going to make available, but they're kind of confusing. So if you want to watch the other video, I'll walk you through how the delta math works, and then you can play with that. It's getting late. I know you guys have to go to bed eventually, but if you want to do a little more work, I'll make that video so that you can. Anyway, thanks for watching. I hope you feel more comfortable. If you don't, see me as early in the morning tomorrow as you can, and I'll try to help you. Bye.